This film is intended for eye surgeons for training and education purposes. Viewer discretion is strongly recommended.
Hi, in this video we'll try to perform a root cause analysis of a complication that's a PC tear, and let's try to dig in deep and understand some of the errors which we've done. Now, this is one of the younger anonymous surgeons performing phacoemulsification on a 70-year-old patient who is having this mature white cataract. The lens is slightly swollen and he's doing all the right things. He's doing a small initial rhexis, he does decompression of the capsular bag, and then he gives a tangential cut to the capsule, extends it. And now we have a decent sized opening. So far so good. Now he begins the sculpting. Obviously the surgeon is planning to do a stop and chop technique. The nucleus is divided into two fragments. The first heminucleus is being chopped into smaller fragments. Now I want you all to observe what are the things being done and make a note of the things which are right and which are not so appropriate. So as we can see, the surgeon is dividing the nucleus into two halves, and then the second half is being again attempted to be divided into two more fragments. It is incomplete, but nevertheless we have got three fragments there, and now the process of emulsification has begun. The fragments are emulsified. Okay, I hope you noted some of the things which are being done. Now he's on to the second heminucleus. He is attempting to do the chop of the second heminucleus, but the grip is not great, and that's the reason why he is unable to get a full thickness groove. It is always happens when you want to do a vertical chop. It is better to have the entire bag filled with nucleus because we don't want the nucleus to slip. Now, because there's no support by the adjacent nuclear fragments, the entire bag is empty. The nucleus is slipping around as it's trying to chop, and that's the reason the chop is inadequate. The nucleus is not separating, and the surgeon is trying to emulsify the nucleus. Probably is trying to get a hold, but nothing seems to happen. It looks like the surgeon is desperate. The nucleus is not so hard, so he may have thought, well, I could as well emulsify the entire fragment into two, and that's what is being done. And this is the last few remnants of the fragment which are being eaten up. And then what we're seeing now is a posterior tear. Well, I'm not sure the surgeon has realized it at this time, but at this stage, it doesn't look to be having any anterior rupture. Doesn't seem to be any vitreous prolapse, but definitely we can see that there is a nice U-shaped tear. One end is visible, the other end is not visible. Probably it is near the equator. Well, the surgeon was lucky in this case. He could manage to place the lens in the bag itself, and the patient did well. So let us rewind and see what exactly happens. We'll start from the second heminucleus. The surgeon is trying to chop the nucleus. He's not able to get a good grip, simply because the nucleus is not stable. All the other fragments are emulsified. The bag is empty. The grip is not good, and he's desperate to get a hold. So he is not able to get a grip and also unable to chop the nucleus. Now we can see a lot of desperation in his movements, trying to get somewhere to hold. And in that process, he has ended up chewing a fair bit of the nucleus, and a part of the nucleus has become extremely thin. But the surgeon is not aware of this thing. He's continuing to do the same measures. And let me slow down here. Now look at the position of the probe. The probe has gone almost near the mid-periphery. And let me zoom in and show you this part of the nucleus is really thinned out. So what happens when you're doing surgery, your primary goal is wrong in this case. The primary goal is to somehow emulsify the nucleus, and in that process, one has forgotten the principles. So the principle should be like the emulsification is secondary, primary should be to be in the safe zone. And unfortunately, the tip is near the thinned out area, and it gives a small burst of phaco, and a hole is created not only in the lens but also in the poster capsule. But at this point, the surgeon is not aware. He goes on and somehow eventually gets hold of the nuclear fragment, pulls it out of the bag, and then emulsify. But at this stage, you can see there is a small stutter there, which was indicating that the PC tear has already happened. And this happens whenever there is a communication between the vitreous cavity and the antechamber. And surgeon has come out without realizing that a PC tear has happened. And now is the time when actually can see a nice C-shaped or U-shaped PC tear staring at him. So it's worthwhile to go back and take a look once again, okay? So the first lesson to learn is when certain maneuvers are not yielding any result, there is no point in continuing the same maneuvers. In this case, the surgeon was not able to get a grip to chop the nucleus. And in the heat of the moment, surgeon has not realized that this maneuver is not working, let me think and do something different. So if you're not able to get a hold, then one should be at least be certain that we are not venturing into the danger areas which the surgeon eventually ventured into and caused the PC tear. So what should have been done? If things are not working out, like you're unable to get a hold and chop and you are forced to chase the nucleus, best thing would be to stop here, ensure that the nucleus come towards us rather than we chasing it. And how do you do that? Put in OVD and maneuver the nucleus out of the bag into the central safe zone. You just put in OVD, use a Sins cube to maneuver it towards the central safe zone or maneuver it out of the bag. So once you are out of the danger zone and in the central area where the phaco probe will be, it is easier to access it and then emulsify. So the message here is ensure that the nucleus comes to the phaco tip somehow. If it is not coming on its own, put in OVD, maneuver it towards the phaco tip and then emulsify, and rather than the phaco tip going and chasing it. So the central rule to be followed always is the phaco tip should never go beyond the central 4 or 4.5 millimeter, because this is the area where we got maximum chamber depth. This is the area where the PC is farthest from the rhexis margin as well as the corneal endothelium. So this is the safe zone for us to emulsify. So lessons to be learned: never chase the nuclear fragment with the phaco tip. Number 2, if the fragment is not coming out, somehow manage to bring it towards the central safe zone and then only emulsify. Number 3, always ensure that the probe is not below the level of the rhexis margin. The emulsification has to be done at the level of the rhexis margin. Number 4, the phaco tip has to be used like a fork to just go in, hold the nucleus, pull it out of the bag, and then bring it to the central safe zone, and then only the emulsification process has to be done, rather than going and trying to eat it in the mid-peripheral region, which could be disastrous. Number 5, always ensure that when you're trying to pick the nuclear fragment and get it into the safe zone, try to modulate your phaco power. It has to be in a position of its least cutting efficiency. So you have to reduce the power. If you're using a longitudinal one, just enough to engage and then pull it out into the central safe zone and then emulsify. If you're using a machine which has got torsional, then switch off the torsional for this particular moment. Go on to the longitudinal mode because it has got lesser cutting ability. Hold it, that is, pick up the nuclear fragment, get it to the center part of the chamber and then emulsify. These are the cases which give us an opportunity to learn immensely. As they say, in hindsight, everything looks very good, but the video recordings do give us a lot of opportunity to, retrospect, analyze, and learn from these mistakes. I hope you found this video helpful. Watch it multiple times so that you get the finer nuances of what I'm trying to tell, and hope you found this helpful. Thank you so much for watching.